Okay, this set is on just starting our unit on limits. This is the first section, so it's the first page of the practice problems. It's going to involve two things, limits from tables and limits from graphs. A limit is it's going to be a little different than what you've done before. A limit, as you can see on the top, describes what happens to the y values of a function as the function approaches a certain x value. So it's kind of like a trend. We're getting closer and closer to this y value. It doesn't matter whether you reach that value or not. And that's the important thing. It's just as you're getting closer and closer. It's not necessarily what the y value is at that point. It's just what you're getting closer and closer to. So as you approach a certain x value, does the y value get closer and closer to a certain number? I'm going to start on the bottom of that note sheet instead of the top. I'm going to start with limits from graphs. So limits from graphs, you're going to follow the curve towards the x value. You could go from the left and you go from the right. Now it's hard to see this notation, but like here, if we look at this graph right here, if I have the limit as x approaches -1, do you see after the -1 up here, it almost looks like an exponent, there's a minus sign. That means the limit as x approaches -1 from the left of this function. So we follow this function from the left. First, we're going towards -1. Well, -1's right here. So as we follow that graph, as we get closer and closer to -1, the y values get closer and closer to 3. Now they actually reach 3, but that doesn't matter. They get closer and closer to 3. So that's the limit as x approaches -1 from the left. Now this next one is the limit as x approaches -1 from the right. You see there's a little plus sign up there like it's in the exponent. That means the limit as x approaches -1 from the right. So we go backwards, so we follow that backwards. It jumps up to here. As we get closer and closer again, here's x equals -1. As we approach that, the y values get closer and closer to 3. So the limit from the left was 3, the limit was right 3. As long as those two are the same, that is our limit as x approaches -1. Our limit is 3. Or here, if we do the limit as x approaches -3 from the left. So we find -3. It's hard to read on my graph. Sorry, 1, 2, 3. Here's -3 right here. This is the axis right here. So as we approach -3. So here at limit as x approaches -3 from the left. Again, that negative sign up in the exponent, that means from the left. So we follow from the left as we approach -3 right here. Our y values get closer and closer to 1, so that's the limit from the left. As we approach -3 from the right, we come backwards from the right. As we approach -3, we're getting closer and closer to 1. Since those are the same, our limit is 1. Most of the time, that's the way it works. If it works like this, it actually reaches that value. If I asked you for, like here, f of -3, well, that is the actual y value. Well, that y value is 1. All right. Now, a little different now here underneath. We have the limit as x approaches 1 from the left. Again, here, see that negative sign. Limit as x approaches 1 from the left. And this is limit notation. This is what it looks like. The limit as x approaches 1 from the left. Well, here's 1 right here. As we come from the left, we get closer and closer to 2. Our y value gets closer and closer to 2. So that's the limit from the left. As we approach from the right, our y value gets closer and closer to -1. So our limit from the left was 2, our limit from the right was -1. Well, since those aren't equal, this limit does not exist. If I asked you to find f of 1, well, that's what we've always done. What is the y value? Well, there's a dot up here at 2, so that is the y value. There was an open circle at 1. If we look at this next graph, similar thing. Here, the limit as x approaches -2 from the left. So here x approaches -2 from the left. So here's -2 right here. As we approach from the left, our y values get closer and closer to 1. So that's our limit from the left. As we approach from the right, our y values also get closer and closer to 1. So our limit is 1. Now it's a little tricky. This is the trickiest kind here at 2. Because notice in our graph at 2, the graph is right here, but there's an open circle right here. So there is no value right there. Notice there's a dot up here above that, up at 2. Now that has nothing to do with our limit. So here the limit as x approaches 2 from the left. Well, if we go backwards towards 2, we're getting closer and closer to 1. We don't reach 1 because of the open circle, but we don't care for limits. From limits, we're going to get so close that it's almost 1. So that's our limit from the left. Our limit from the right, so as we come backwards, we also get closer and closer to that open circle. So it's like just barely above 1, like 1.0001. So we're getting closer and closer to 1. That's our limit. So here our limit as we approach 2 is actually 1, even though there's an open circle there. Now, if I asked you for g of 2, well, g of 2 is 2 because that's where the dot's at. Here, if we were doing the limit as x approaches 0, so down here in the bottom, the limit as x approaches 0 from the left. Well, 0 is the y-axis, so as we approach from the left, we're headed to negative infinity because we just keep going down and down and down. So that's our limit from the left. Our limit from the right, as we come backwards, we're also going to keep going down. That's also negative infinity. So our limit as x approaches 0 is negative infinity. A lot of times you'll see that listed as does not exist, which is fine. But a better answer is negative infinity because that describes more what's happened. If I just said does not exist, you really wouldn't know what it looked like. But if I said it approaches negative infinity, you have a good idea. So that's limits from graphs. There's some notes on there about what to do and stuff there. All right. Now, limits from tables. Limits from tables, I can tell you from personal experience, this was much easier when they invented the graphing calculator. This was a lot harder before graphing calculator because you can do all this on your graphing calculator. So like this one here, if we want to find the limit as x approaches, I can't read that, as x approaches 1 of x minus 1 over x cubed minus 1. So that's the limit we're looking for. We're going to do that with a table. So on your table, the first thing to do is, I think we've done this before, on the instructions on the top, you're going to go second table set. You can see that on here. Notice down here where it says independent, we want ask to be highlighted. So you want your screen to look like that. It's important. That one says ask. The dependent variable says auto. Okay, that's what you need to do for these tables. Okay? Now, next we need to put our function in there. So we're going to go to y equals, and we're going to put in that function x minus 1 over x cubed minus 1. So I'm going to put in parentheses, make sure the top is in parentheses when it's got multiple things up there, x minus 1, close the parentheses, divided by, then start a new parentheses on the bottom. We have x to the third minus 1 and close the parentheses. So it should look like that. Now go to second table. Now we're doing as x approaches 1. So we want to start with some numbers pretty close to 1, but we want to get closer and closer to 1. Well, pretty close to 1. You see, best to do this by decimal places. You can see on the chart I put on your paper, I started with 0.9. 0.9 is pretty close to 1, so I'm going to put in 0.9. Notice a number showed up in there. Then I'm going to go closer by a decimal place, so I'm going to do 0.99. 0.999. That's what I mean by getting closer by decimal places. You can hopefully see that on there. You can see that on my screen. Then I'm going to put in 1. Notice when I put in 1, it says error, because if you plugged 1 in here, the denominator is going to be 0, and we can't have that. That's okay. Now we're going to go on the numbers greater than 1. We're going to do this backwards. So we're going to put 1.001, 1.01, and 1.1. So now you want to look at your calculator, and we're going to do the limit off this. If you start from the top, this is the limit as we approach 1 from the left. So we're approaching for numbers less than 1. You can see our numbers get closer and closer here. You got 0.33367. Well, that looks to me like if you think of a number you might be familiar with, like 0.33333, which is 1/3. So that's our limit from the left. Then as we approach from the right, you start from the bottom and go backwards. So if we go up towards 1, again, do you see we're getting closer to 0.33333? So it looks like we're from the left, we're approaching 0.333. From the bottom, we're approaching 0.333. So from that, if you look at your table, you could say, well, it looks like our limit is probably approaches 0.333. So chances are it's 1/3. So the limit as x approaches 1 from the left was 0.333. The limit as x approaches 1 from the right was 0.333. So our limit is 0.333. So it's real easy to just put those numbers into your calculator, and then here we just write down the numbers that showed up. That's the beauty of the second Calc Ask. Let's try this next one. This is kind of a fallback towards trig. Here we're finding the limit as x approaches 0 of sine x over x. Notice it says radians. Whenever you do these, if you have a trig function, sine, cosine, tangent, whatever, you need to be in radians. So first thing on my calculator, I'm going to go to mode, and I'm going to make sure I'm in radians down there. Now go to y equals. I'm going to clear that old one off. Now we're going to put sine of x. So on the top, I'm going to put the sine of x, close that parenthesis, divided by, and on the bottom, I put an x. So we enter that function in our calculator. Now go to second table. Again, the table is up there. Second table. Now we're approaching 0. So we need some numbers left of 0. Well, those are going to be negative numbers. So again, we're going to start fairly close to 0. We're going to go by decimal places. So let's start with negative 0.1. And you can see these in the table. Negative 0.1, negative 0.01, negative 0.01, and negative 0.001. So if you can see there, we're getting closer and closer to 0 from the negative side. I'm going to go ahead and put in 0, and notice it says error again because there's an x on the bottom. That means the bottom is 0. Now on the right side of 0, we're going to do the same thing, only kind of backwards. Let's start with 0.001, 0.01, and 0.1. Okay? So you can see here we're approaching from the left, so we're have negative numbers getting closer and closer to 0. Here we're approaching from the right. As we go backwards here, we're approaching 0 from the positive side. Now you fill in the table. Again, you see those numbers that showed up there. You see that on the thing, those are numbers we filled into the table. Well, if you look at those, as we approach from the left, we're getting closer and closer to 1 here. Your calculator even rounded it off to 1 because it couldn't get any closer. So our limit from the left was 1. If we go backwards here, our limit from the right is 1. So our limit as x approaches 1 of that function is 1. When you're asked to fill in the table, you need to keep as many decimal places as you can. So don't just round it off to like 1 decimal place. Notice here, I kept 5 decimal places so I could really see what was happening. Same way in the top one, I kept 5 decimal places. So that's limits from graphs and limits from tables. Again, if you're asked to do a limit from the table, it's important you fill in all the numbers in the table. And again, the notes on how to do that are on your note sheet about how to set your calculator correctly. And I think that's it for the first section of limits. Thank you.